Hello, everybody. Today, I can basically practice all the types of transformations I've already learned. I can translate by counting on the graph. I can rotate by turning my paper. I can reflect over a line by counting to what I'm reflecting over in one direction, and I can reflect through a point by counting to what I'm reflecting through in both directions. A line, you can only count in one direction. A point, you count in both directions. So we're going to go over one example of each. That's what your quiz is going to be on. So let's get to it. I've got triangle tap. I got t is negative 1, 4. I've got a is 2 comma 4. I've got p is 2 comma 0. I want to reflect it through negative 2, negative 2. So let's take a look at negative 2, negative 2. To reflect through a point, I count in both directions to what I'm reflecting over. So let's start with t. To get from t to that point of reflection, I'm going left 1, down 1, 2, 3, 4, 5, 6, left 1, down 1, 2, 3, 4, 5, 6. That's t prime. A, I'm going left 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. So that's left 4, down 6, left 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. That's A prime. P, I'm going left 1, 2, 3, 4, down 1, 2. That's left 4, down 2, left 1, 2, 3, 4, down 1, 2. That's P prime. There's my new triangle. It should look the same as far as the same size, the same shape. It just got reflected through that point. And again, a point reflection is a rotation of 180. It does not change the orientation. Is it asking me to state the coordinates? No, I'm good. Number 2, I got triangle XYZ with X negative 3, 4. Y negative 1, 1, Z 2, 2. It wants me to translate it 3 left and 1 up. So I'm going to take each point and I'm going to count 3 left and 1 up. For X, 1, 2, 3 left, 1 up. For Y, 1, 2, 3 left, 1 up. For Z, 1, 2, 3 left, 1 up. Connect them. Boom. There it is. It says graph and label it. It's labeled. I'm done. 3, I have L, 2, negative 3. I got M, 5, 1. I've got Z, 7, 3. For N, 7, 3. 2, negative 3, 5, 1. Yep. Kind of a narrow situation here, but whatever. And it wants me to rotate it 90 degrees, counterclockwise, 90 degrees, centered at the origin. So to rotate, I turn my paper. Counterclockwise is to the left, 90 degrees is 1/4 turn. L prime, M prime, N prime. L is now, so this is my new origin. It's 3, 2. M is negative 1, 1, 2, 3, 4, 5. N is negative 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Remember, the numbers themselves won't change. So if I had 2 and a 3 here, I'll have a 2 and a 3 there, 5 and a 1, 5 and a 1, 7 and a 3, 7 and a 3. It's just they may get negated and or switched depending on what the rotation is. So now I can just get rid of this. I'm going to plot the new points. I've got L is 3, 2. I've got m is negative 1, 5. L prime, m prime, n prime is negative 3, 7. And I know it's kind of a weird shape, but whatever. All right. To do a rotation, I turn the paper. And finally, for a reflection over the line x equals 1, well, I need to know what x equals 1 is. I need to see it. Yancey has X-ray vision. X equals a number is a vertical line. If it was y equals a number, it would be a horizontal line. So I make a vertical line at x equals 1. That's middle line and reflect over. So let's get D8, negative 2 on the graph. Let's get E6, 3 on the graph. Let's get F2, 7. And if I want to reflect over that line, I count to the line I'm reflecting over. So to get from F to that line, I'm going left 1, so go left 1 more. That's F prime. For E, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm not counting to the axis, I'm counting to the line x equals 1. For D, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's my new picture. It looks good. I'm done. So a line reflection, I count to what I'm reflecting over in one direction. A rotation, I turn my paper counterclockwise. Left is to the top, clockwise, top is to the right. Do whatever it says, it has to say. Translation, I just count on the graph. And point reflection, I count in two directions to the point that I'm reflecting over, and then I do the same thing through the other side. Practice it, get it right, move on with your life. Goodbye.